Welcome to Miss Taylor's class notes, and today we're going to talk about our vertex form. So we've spent the last two sets of notes talking about transformation and changing our parent function. So now that we know how to change our parent function, we're going to introduce you guys to our vertex form. So if we change the number in front of the parentheses, it was a vertical, either stretch or compression. If we change the number after x inside the parentheses, it was a horizontal shift, either left or right. And if we change the number after the parentheses, it was a vertical shift, up or down. And then we also talked about if we change the number in front of x, but inside the parentheses, that was our horizontal stretch or compression. So we're going to go ahead and graph this based on what we know. So we know that our vertex is going to be 3 to the right and 1 up. So 1, 2, 3, 1 up. We know that if it's if our A value is 2, it's going to be stretched. So it's going to go like this. So our vertex, we already said, was going to be 3 to the right and up 1. So our vertex is going to be 3, 1. And if we notice very quickly, we took the 3 from there and we took the 1 from there. So those two numbers are what represent our vertex. So our vertex is the number, or our x of the vertex is after x inside the parentheses. Our y is the number after the parentheses. So when we talk about vertex form, we talk about h and k. So our h and our k are the vertex. They are our x, y. And then the value of our a determines two different things. First, which way the parabola P opens, and it determines how wide the parabola is. So, sorry, my vacuum decided to go off. So if we look at our vertex, we know our vertex is h and k. H, k. So we've got to remember, just like we did in transformations, we've got to flip the sign. The negative tells me it's on the right, which is positive. So we're going to have a positive 5, 2. Same thing here. If it's a positive, we've got to do the opposite, which is negative 6. And then we write down that 4. And then if there's no number at the end, our number is simply 0. So we've got to flip the sign, and so it becomes a positive 10, 0. So to remember, our max is when we have a negative a, because that's the highest it goes, because it's a frowny face. A min is a positive a, because we have a smiley face. So we're looking at this number here, and that number is 1, so that tells us it's going to be a min. And the value of our minimum is we're looking at the y number of our vertex, so it's 2. So again, we're looking at the number in front of our parentheses. It's positive, so it's going to be a minimum. And then again, we're looking at that y value. If it's negative, it's going to be a max. And again, we're looking at that y value. So we can find a lot of information about our equations if they're in vertex form. So equations that are written in vertex form can be converted into standard form by simply doing what we learned in our previous unit. So we have a binomial that is squared, which means we can do our box method. Do x minus 4, x minus 4. Let me switch to red to color code things a little bit more. So we get x squared minus 4x plus 16. And if we combine our like terms, we get x squared minus 8x plus 16. And then, go away box. We're just going to simply bring down our plus 5, and we're going to combine our like terms. So we get x squared minus 8x plus 21 is our standard form equation, which should go right there. But again, if they give it to us in vertex form, we can very quickly find out our vertex. We've got to flip the sign of what's inside the parentheses, and then we put what's outside the parentheses down next. So again, I'm going to find the vertex first because a lot of times that's easier. We got to flip our sign, so it's going to become negative. There's nothing after the parentheses, so it's going to be 0. So now, when I'm looking at this, nope, go away. I'm going to use a rule that we learned while we were multiplying binomials. This is a perfect square binomial. So if it's a perfect square and binomial, I'm going to square the first term. I'm going to multiply the first term times the second term times 2 because I would have to combine those like terms. So that's going to be plus 4x. And then I'm going to square the second term plus 4. I'm going to leave it in its parentheses, and then I'm going to bring down the 3. So now that we've got that number next to a parentheses, we simply distribute. And so we get 3x squared plus 12x plus 12 as our function. All right, so I want you to find the vertex, and then I want you to find the standard form. And the only thing tricky about this question is we have to remember that -1 right there. So you can use the box method, you can use your perfect square trinomial rule, however you want to find h of x. And if you want to prove that they're equivalent, which means they're the same, you should be able to graph both in Desmos, and they should be the exact same equation. All right, so how can we write an equation using vertex form? So vertex form can be used to write quadratic equations when we're given the vertex and another point on the graph. So this first one just wants us to write it in vertex form, but step 1 is going to be that we're going to plug the vertex and the given point into our vertex equation. So what that means is I'm going to make my vertex is going to be my h and my k, and then my point is going to be my x and my y. So I'm going to rewrite our vertex equation. Y equals a parentheses x minus h squared plus k. So I'm going to substitute my y in for y, so we're going to write down 2. Then I don't know what a is. This is what we're solving for. This is what we have to find. Then I'm going to write down my parentheses. My x is 0 minus, and then I'm going to put in my h, which is 1. Then I'm going to square it, and then I'm going to put plus my k, which is 1. So again, our point is going to be x and y. Our vertex is going to be h and k. So the first thing that I'm going to do is I'm going to subtract 1 from both sides. So 2 minus 1 is 1 equals a parentheses 0 minus 1 squared. Now I'm going to do what's in my parentheses. So 1 equals a, 0 minus 1 is -1 squared. And then I'm going to go ahead and square that -1. So 1 equals a -1 times -1 is a +1. And I'm going to put that number in front of a. And we know that if you want to, you can go ahead and divide the 1. And so 1 divided by 1 is simply 1. So if we go and we put this in vertex form, we're going to replace the y with y. My a is going to be 1. We're going to do x minus, our h is 1 squared plus 1. And so that is our vertex form equation. It technically wants g of x instead of y, and we technically don't have to write that 1. And so both of these are correct. Both of these are the same thing. Okay, so our vertex is h, k, and then we've got a point which becomes x and y. So I'm going to rewrite my basic equation. Y equals a, x minus h squared plus k. And now I'm going to replace everything in there. Our y is 0. We are looking for a. We don't know what it is. Parentheses x is -4 minus, but since h is negative, I'm going to have a double negative and it becomes positive, squared plus our k, which is 8. So again, I'm going to get the 8 out of the way. I'm going to move it to the other side. So I get -8 equals a, parentheses, -4 plus 2 squared. Now I'm going to do what's in the parentheses. So -8 equals a, and -4 plus 2 is -2, and I'm going to leave it squared. A -2 times -2 is a +4. And I'm always going to put that number in front of the a so that just makes it easier, makes the math a little bit simpler. I'm going to divide by 4, and a equals -2. So once we find that -2, we're going to write it. It wants us to write it in standard form. So we first have to write it in vertex form. Y equals, our a we said is -2. We're going to go back to x. We put +2 in our equation squared, plus 8. So again, I'm going to use my perfect square trinomial rule because it makes the math a whole lot easier. I can do it in my head. -2, I'm going to square the x. The number in front of x is 1, so 1 times 2 is 2. There's going to be 2 of those terms, so I'll multiply it by another 2, so plus 4x plus 4, and then we have plus 8. So here, order of operations matters, which is why I always want to leave that trinomial inside the parentheses, because I need to multiply next. And so once I distribute, we get -2x squared minus 8x minus 8 plus 8. And our last step is to combine our like terms. Those are going to cancel. So I'm left with y equals -2x squared minus 8x. All right. So we're given a vertex. And we're given 2 points. You can pick whichever point you want to use. You can use 5, 1, or you can use 1, 1, whichever one you want to do. And I want you to go ahead and write it in vertex form. And then I want you to write it into standard form. All right, Mr. Turner graphs the two functions. One has a vertex at 2, 10. And passes through the point 2, 0. The next function is h of x equals here. So it's asking which function has the greater maximum. Now remember, our maximum is simply our vertex, and our maximum tells us it's the highest point. And our maximum is also the y value of our vertex. So our first function, I'm looking at the y value of our vertex, so the max is 10. So now in our next function, I've got to look through my vertex. We've got to flip the sign of what's inside, 8. So my y value is 8. So the max is 8. So our first function has the higher maximum. All right, I want you to go ahead and graph this and that. Actually, you don't need to graph this in Desmos. Go ahead and graph this in Desmos and answer these questions here. And if you mark false, I want you to go ahead and fix it and write the correct answer to make it true.